Hello everyone, today in this video I'm going to teach you the 5th chapter of class 10, that is Arithmetic Progression. So Arithmetic Progression. So in order to try to understand this arithmetic progression, we will just list out some series of numbers. Suppose a series of natural numbers. 1, 2, 3, 4, 5, 6, 7, and so on. A series of numbers, multiples of 5. 5, 10, 15, 20, and so on. A series of perfect squares. 1, 4, 9, 16, 25, and so on. Okay. A series of even numbers. 2, 4, 6, 8, 10, and so on. So these are some of the series of numbers that I have listed out. Now, first of all, we will see what is a sequence. Sequence means a series of numbers or a series of terms arranged in a certain pattern or arranged following a certain rule. Now let's see. Here the first series of numbers, 1, 2, 3, 4, 5, 6, 7. All these numbers are natural numbers in increasing order. So this series of numbers is following a certain rule, as it's following a certain pattern. Natural numbers in increasing order. So it is a sequence. Now let's look at the second one. The second series of numbers are 5, 10, 15, 20, and so on. Now, these numbers are all these numbers are multiples of 5 in increasing order. So it is a sequence. The third series of numbers are all perfect squares in increasing order. So it's following a certain pattern, so it is a sequence. The last series of numbers, 2, 4, 6, 8, 10, and so on, this series of numbers are also following a certain pattern. That is, even numbers in increasing order. So it is a sequence. Now, what is an arithmetic progression? So we'll define arithmetic progression as: arithmetic progression is a sequence in which the difference between each of the consecutive terms are equal. Means, now look at the first series of numbers. We have clearly seen that all these series of numbers are sequence. Now let us check whether they are arithmetic progression or not. Let's check which of these sequences are arithmetic progression. The only thing that we need to work out is, in order to check whether the given series of numbers is arithmetic progression or not, we have to check the difference between each of the two consecutive terms. Let's see. The first series is 1, 2, 3, 4, 5, 6, 7, and so on. Now here, the first term is your 1, so first term we can write A1 or simply A. Second term A2, third term A3, fourth term A4, fifth term A5, and so on. Now, we will check the difference between each of the consecutive terms. Like second term minus first term. So that is 2 minus 1, which gives you 1. So the difference between the second term and the first term is 1. Now let's check the difference between the third term and the second term. A3 minus A2. The third term is 3, second term is 2. So 3 minus 2, 1. So this means the difference between the second term and the first term and the difference between the third term and the second term, they are both equal. That means difference between these consecutive terms are equal. Now the same should hold for each of these consecutive numbers. Now let's check. Let's check fifth term minus fourth term. A5 minus A4. So the fifth term is 5, the fourth term is 4. 5 minus 4, 1. So see, since each of in this sequence, since the difference between each of the consecutive terms are equal, so this particular sequence or this particular series of numbers is an arithmetic progression. Let's check some more examples. Let's look at the third series of numbers. The third series of numbers. 1, 4, 9, 16, 25, and so on. Now, this series of numbers is a sequence because it is being arranged in a certain pattern or following a certain rule. All these are perfect squares in increasing order. Now let's check whether they are arithmetic progression or not. Now the first term, the second term of the series, the third term of the series, the fourth term of the series, the fifth term of the series, and so on. Now let's check the difference between each of the consecutive terms. Now, this second term minus first term. Second term 4 minus first term 1, which gives you 3 as the difference. Now let's see the difference between the third term and the second term. That is 9 minus 4. So 9 minus 4, that is 5. It means from these two steps we can conclude that the difference between the first two terms is 3, while the difference between the next two consecutive terms is 5. That means the differences between the consecutive terms are not equal. So we can conclude that this given series of terms of numbers is a sequence but not an arithmetic progression. Now, since this syllabus is strictly based, this video is strictly based on NBSE syllabus of class 10. So, let's try to work out some of the questions that is given in the syllabus. Okay. First, let's see exercise 5.1, question number 2. It is write first 4 terms of the given AP, arithmetic progression, when the first term A and the common difference D are given. Now, let's first take an example. Now, let's consider a series of numbers which is an arithmetic progression. Example 10, 20, 30, 40, 50, and so on. So this given series is an arithmetic progression. So the first term of the series is 10. So the first term of the series is always denoted by A or sometimes A1. So A is the first term of your series, that is 10. Now in this case, this series of numbers is an arithmetic progression. So the difference between each of the consecutive terms are equal. So the difference between 20 and 10, second term and first term is 10. The difference between third term and second term is 10. The difference between fourth term and third term is 10, and so on. That means the difference between each of the consecutive terms are equal, and it is equal to 10. That 10 is known as your common difference. So in this example, in this given arithmetic progression, the first term A is your first term of the series 10, and the common difference, that is D, is also equal to 10. Now, so from exercise 5.1, question number 2, we'll solve out Roman 1, question Roman 1. A is given to be 10. Now D is given to be 10. Means the first term of the series is given to be 10, and the common difference is given to be 10. Now we have to write first 4 terms of the arithmetic progression. So solution. The first term is given to be 10, which is your first term. Now we have to find out the next following terms. So the second term of your arithmetic progression, we can write it as A2. Now the second term can be found out by adding its preceding term and with the common difference. The preceding of the second term is your first term. With the first term, you add the common difference. That gives you the second term. Your first term is given as 10. Your second term is also given as 10. So 10 plus 10 gives you 20. So the second term of your arithmetic progression is 20. Now we'll follow the same rule for finding out the third term, the fourth term, and so on. Now the third term, denoted by A3, can be found out by adding its preceding term with the common difference. So that the preceding term to third term is your second term. Second term is preceding to third term. So with the preceding term of third term, that is A2, we add the common difference. So that is, your second term is 20 plus common difference is 10. That gives you 30. Now to find out the fourth term, denoted by A4, with its preceding term, which is third term, we add the common difference. So that is 30 plus 10, that is 40. So this gives you the first term, the second term, the third term, and the fourth term of your given arithmetic progression. The same way, using the same method, we can work out the remaining questions given in this question number 2. Now we'll try another one. It is Roman 3. The first term A is your first term of the series given to be 4. D, the common difference is given to be -3. So the same question, we are going to find out the first 4 terms of this given A. So the second term, denoted by A2. Second term, in order to find out the second term with its preceding term, it is first term, we add the common difference. first term is given as 4 plus common difference is given to be minus 3. So 4 plus minus gives you minus 3. 4 minus 3 gives you 1. Now, an arithmetic progression can be in terms of increasing order or it can be in terms of decreasing order. In this case, we get in terms of decreasing order. Now, let's look at the third term of the sequence of the arithmetic progression. So, third term. In order to find out the third term with its preceding term, that is second term, we add the common difference. The preceding term, second term is 1 plus common difference is minus 3. So 1 plus minus 3 gives you minus 2. So it gives you the third term of your arithmetic progression. Now let's look at the fourth term of your arithmetic progression. Fourth term denoted by A4. Now in order to find out the fourth term with its preceding term, the third term, we add the common difference. Now its preceding term is minus 2. Common difference is minus 3. Minus 2 plus minus 3 gives you minus 5. So the first term, the second term, the third term, and the fourth term of your arithmetic progression has been determined. Now let's go to question number 3. Question number 3. For the following arithmetic progressions, write the first term and the common difference. Let's see the first one. The given series is 3, 1, minus 1, minus 3, and so on. So this is your given arithmetic progression. It says for the following arithmetic progression. So all the series that is being given in question number 3 are arithmetic progression. Now let's start with the solution. So for this arithmetic progression, we are asked to write the first term. First term means the first term of your given series is your first term. So the first term, in the previous question we see that the first term is denoted by A or simply A1. So that A is given by, here the first term of your series is 3. So A is equal to 3. And the common difference, we see that in the previous question common difference is denoted by D. And how do we find out the common difference? We subtract any of the consecutive terms. So this is your first term, this is your second term, this is your third term, this is your fourth term, and so on. So we can subtract any of the two consecutive terms. But the subtraction goes, suppose if you are choosing the first term and the second term, then you have to subtract second term minus first term. If you are going to subtract the next two terms, that is the second term and the third term, then we have to follow third term minus second term. And if you are to subtract the next two terms, then we have to subtract the fourth term. Every term must be subtracted with its preceding term. In order to find out the common difference, the particular term that we choose has to be subtracted with its preceding term. Suppose in order to find out the common difference D, I choose the third term, okay, A3. Now with the third term, I have to subtract its preceding term, that is A2. So your third term of the series is minus 1 minus your second term of your series is 1. So minus 1 gives you minus 2. So the first term and the common difference of your given arithmetic progression has been determined. Let's see another one Roman 3. In Roman 3, the given arithmetic progression is 1 by 3, 5 by 3, 9 by 3, 13 by 3, and so on. So the solution. Here, the first term of your given arithmetic progression is 1 by 3. So first term, A is equal to 1 by 3. Now the common difference. The common difference denoted by D. Now in order to determine the common difference, we can choose any term of the AP, but with that term we have to subtract its preceding term. Suppose we choose the fourth term, A4. Then with this fourth term, we subtract its preceding term, that is third term. Now your fourth term is 13 by 3, your third term is 9 by 3. Now this gives you 13 minus 9 by 3. It gives you 4 by 3. So the first term of the series and the common difference of your series has been determined. Now let's see the fourth question. It is question number 4. In question number 4, which of the following are arithmetic progressions if they form an arithmetic progression? Find the common difference D and write 3 more terms. Now in this question we are asked to check which of the following are arithmetic progressions. If they are arithmetic progression, we have to note down its common difference and we have to write 3 more terms of the series. Let's look at the first one. It's Roman 1, 2, 4, 8, 16, and so on. Now the solution. So this is your first given series. Let's determine whether it is an arithmetic progression or not. It is very simple. If the difference between each of the consecutive terms are equal, then the given series forms an arithmetic progression. Now how we check out the difference? You can choose any term of this series. Suppose I choose the third term. Then to this third term, you have to subtract its preceding term, that is the second term. So the subtraction has to be done in this way. Third term minus second term. Now let's check. Now here your first term, suppose A or A1, first term of the series is 2, second term of the series is 4, third term is 8, fourth term is 16, and so on. Now let's check the difference between each of these consecutive terms. If I choose the second term, then I have to subtract its preceding term. It is 4 minus 2, which gives you 2. If I choose the third term, then I have to subtract its preceding term, that is A2. So 8 minus 4, that is equal to 4. Now if I choose the fourth term, then I have to subtract its preceding term, it is A3. So 16 minus 8, that is 8. Here we see that the difference between the consecutive terms are not equal. Therefore, the given series is not an arithmetic progression. Since the difference between the consecutive terms are not equal. Therefore, the given series is not an arithmetic progression. Now let's check out some more questions. Suppose we work out with Roman 5. The given series is 3 plus root 2. This is one term. This is also one term. 3 plus 2 root 2. 3 plus 3 root 2. And so on. Now we first determine whether this given series is an arithmetic progression or not. Here, the first term, the second term, the third term, and the fourth term. In order to determine whether the given series is an arithmetic progression, we check out the difference between each of the consecutive terms. Now, as in the previous question, we choose any of the term in this series, A2. Now, we always need to subtract with its preceding term. That is, we have to subtract with A1. So your second term is 3 plus root 2 minus first term is 3. Positive 3, negative 3 can be cancelled out. So that gives you square root of 2 as the difference. If I choose the third term, then I have to subtract with its preceding term, that is A2. Now the third term is 3 plus 2 square root of 2 minus the second term. I will enclose it in the bracket within the parenthesis, that is 3 plus square root of 2. Now 3 plus 2 square root of 2 minus 3 minus plus minus square root of 2. Now positive 3, negative 3 can be cancelled out. So 2 square root of 2 minus square root of 2 gives us square root of 2. Now the differences in both the cases are equal, but that's not enough. Let's check the difference between the next two terms. If I choose the fourth term, then I have to subtract with its preceding term, that is A3. Now the fourth term is given by 3 plus 3 square root of 2 minus the third term. I will enclose within the parenthesis and write down the third term. Now 3 plus 3 square root of 2 minus 3, we open the parenthesis, minus plus minus 2 square root of 2. Then this positive 3, negative 3 can be cancelled out. Then 3 square root of 2 minus 2 square root of 2 gives us square root of 2. Now, in all the three cases, we see that the differences are equal. So the difference between each of the consecutive terms are equal, so the given series is an arithmetic progression. Since the difference between the consecutive terms are equal, therefore it is an arithmetic progression. Now, the condition was that if it is an arithmetic progression, we have to find out, we have to write the common difference, which we have determined is the square root of 2, and we have to write the 3 more terms. Now, This is your first term, second term, third term, fourth term. So 3 more terms. So we find out the fifth term. So fifth term denoted by A5. Fifth term means with its preceding term, as we have seen in the previous questions, with its preceding term, we add the common difference. In order to find out the succeeding term, with its preceding term, we always need to add the common difference. So your fourth term of the series of your arithmetic progression is 3 plus 3 square root of 2 plus common difference is determined to be root 2. So 3 plus 3 square root of 2 plus square root of 2 gives us 4 square root of 2. Now we have to determine the next 2 terms as well, that is the sixth term and the seventh. The sixth term of your arithmetic progression, sixth term denoted by A6. Now in order to find out the sixth term with its preceding term, it is the fifth term, we add the common difference. Now the fifth term was determined as 3 plus 4 square root of 2 plus common difference is root 2. So that is 3 plus 4 square root of 2 plus square root of 2 gives us 5 square root of 2. The seventh term, that is A7. In order to determine the seventh term with its preceding term, that is sixth term, we add the common difference. And the sixth term is 3 plus 5 square root of 2. The common difference is root 2. So that is 3 plus 5 square root of 2 plus square root of 2 gives us 6 square root of 2. That's your complete solution. Now let's check out some more questions. Roman 9. The given series is 1, 3, 9, 27 and so on. So we have to check whether this given series is an arithmetic progression. So let's see. In the given series, the first term is 1, second term, third term and fourth term. Now in order to determine whether it is an arithmetic progression or not, we find the difference between the consecutive terms. Now we can choose any of the term of this sequence. Suppose we choose the second term. With the second term, we always subtract its preceding term. It is A1. We don't choose A1. Why? Because the first term has no preceding term. So we always start with the second term. Second term is 3 minus first term is 1. That gives us 2 as the difference. If we choose the third term, then we have to subtract its preceding term. That is A2. Now the third term is given to be 9. The second term is given to be 3. So 9 minus 3, 6. From these two cases, we can see that the differences are not equal, as 2 is not equal to 6. So since the difference between the consecutive terms are not equal, therefore this given series is not an arithmetic progression. Since the difference between second term and first term is not equal to the difference between third term and second term, therefore the given series is not an arithmetic progression. Now let's see the last question, that is Roman 10. Your given series is A, twice A, thrice A, 4 times A, and so on. Now, in order to check whether it is an arithmetic progression or not, we check the difference between the consecutive terms. We always start with the second term. We don't choose the first term. Why? Because the first term has no preceding term. So we start with the second term. So this is your first, second, third, fourth term, and so on. Now, if we choose the second term, then with the second term, we have to subtract its preceding term, that is a1. Now, the second term is given to be 2a, the first term is given to be a. Twice a minus a gives you 1a, or simply a. If we choose the third term, then with the third term we subtract its preceding term. So the third term is given to be thrice of a, minus second term is given to be twice of a, which gives you a as the difference. Now if we choose the fourth term, then with this fourth term we subtract its preceding term. So 4a minus the third term is 3a, which gives you a. Now in all those cases, we see that the differences are equal. Therefore, the given series is an arithmetic progression. Since the difference between first two terms is equal to the difference between the next two terms is equal to the difference between the next two terms, and so on. Therefore, it is an arithmetic progression. Now here we see that the common difference is equal to a. Therefore, common difference, which we denote by d, is equal to a. Now we have to find the three more terms of this AP. Now, it's very obvious that the first term is a, second term is 2a, third term is 3a, fourth term is 4a. That means the fifth term will be given by 5a, the sixth term will be given by 6a, the seventh term will be given by 7a. Suppose that 21st term will be given by 21a, and so on. So, therefore, the fifth term, a5, will be given by 5a. The sixth term, a6, will be given by 6a. The seventh term, a7, will be given by 7a. That is the complete solution. So if